What are waves? Waves are everywhere in our everyday life, whether we can see them or we cannot. For example, when you're surfing, you're watching waves. Water waves are in our everyday life when we get sun, when we heat up our foods in the microwave. But what exactly is it? So, a wave can be thought of a disturbance or oscillation that travels to space time accompanied by a transfer of energy. The direction of a wave propagates in a perpendicular direction and it oscillates for transverse waves. And a wave does not move mass in the direction of propagation, it transfers energy. Very important things for understanding a wave, for example, a medium. A medium is the material or empty space through which signals, waves, or forces pass. Direction of propagation, the axis along which the wave travels, and a wave, a moving disturbance in the energy level of a field. Longitudinal waves. In a longitudinal wave, the particle displacement is parallel to the direction of the wave propagation. The animation shown shows a one-dimensional longitudinal plane wave propagating down a tube. The particles do not move down the tube with the wave. They simply oscillate back and forth about their individual equilibrium positions. Transverse waves. In a transverse wave, the particle displacement is perpendicular to the direction of the wave propagation. As you can see, the animation below shows a one-dimensional transverse plane wave propagating from left to right. As is very obvious over here, the particles do not move along with the wave. They simply oscillate up and down about their individual equilibrium positions as the wave passes by. Just pick a single particle and watch its motion, how you are going to see how they oscillate up and down on their individual equilibrium. Water waves. Water waves are an example of waves that involve both longitudinal and transverse motions. As a wave travels through the water, the particle travels in clockwise circles. The radius of the circles decreases as the depth into the water increases. The animation shown shows a water wave traveling from left to right in a region where the depth of the water is greater than the wavelength of the waves. I have identified two particles in orange to show that each particle indeed travels in a clockwise circle as the wave passes. Surface waves. Another example of wave with both longitudinal and transverse motions may be found in solids as Rayleigh surface waves, named after John W. Stuart III, Baron Rayleigh, who first studied them in 1885. The particles in a solid through which Rayleigh surface wave passes move in elliptical paths, with the major axis of the ellipse perpendicular to the surface of the solid. As the depth into the solid increases, the width of the elliptical path decreases. The Rayleigh surface waves are the waves that cause most damage during an earthquake. They travel with velocities slower than S waves and arrive later, but with much greater amplitudes. These are also the waves that are mostly easily felt during an earthquake and involve both up and down. Mechanical wave. A mechanical wave is a wave that is an oscillation of matter, and therefore transfers energy through a medium. While waves can move over long distances, the movement of the medium of transmission, the material, is limited. Therefore, the oscillating material does not move far from its initial equilibrium position. Mechanical waves transport energy. This energy propagates in the same direction. Electromagnetic waves. In physics, electromagnetic radiation, or EM or EMR, refers to the waves, or their quanta photons, of the electromagnetic field, propagating or radiating through space, carrying electromagnetic radiant energy. It includes radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Electromagnetic radiation consists of electromagnetic waves, which are synchronized oscillations of electric and magnetic fields that propagate at the speed of light. Wave frequency. The number of waves that pass a fixed point in a given amount of time is wave frequency. Wave frequency can be measured by counting the number of crests, or high points, of a wave that passed the fixed point in 1 second or some other time period. The higher the number is, the greater the frequency of the waves is. The SI unit for wave frequency is the hertz, or Hc, where 1 hertz equals to 1 wave passing a fixed point in 1 second. The figure shown below shows a high frequency and low frequency transverse waves, where the red one has a lot of high frequency waves and a lot of crests, while the low frequency wave we can see 2 big peaks or 2 big crests.
Period. The period of a wave is the time of a particle on a medium to make one complete vibrational cycle. Period being a time is measured in units of time such as seconds, hours, days, or years. The period of orbit for the Earth around the Sun is approximately 365 days. It takes that for the Earth to complete a cycle. The period of a typical class at high school may be 55 minutes. Every 55 minutes a class cycle begins. Amplitude. Wave amplitude is the maximum distance the particles of the medium move from the resting position when a wave passes through. A wave caused by disturbance with more energy has greater amplitude. Trampoline. One example of this wave moving toward a stage outline skin of spring.
What are
if
they
you
doing,
compress
Ivan?
one portion of the slinky
Jumping?
and
You
let
have to
go,
wait
the
now
wave
because
will
they're
move
too big.
left to right at the same time. The
They'll
disturbance,
knock you down.
which is the coils of spring
You see,
moving, will also
Megan,
move
you're so
left to right.
tan.
Guitar. Another classic example of longitudinal wave is sound. A sound wave is produced by vibrating object. As a guitar string vibrates, it sets surrounding air molecules into vibrational motion. The frequency at which these air molecules vibrate is equal to the frequency of vibration of the guitar string. The back and forth vibration of the surrounding air molecules create a pressure wave which travels outward from its source. This pressure wave consists of compression and reflection. The compressions are regions of high pressure, where the air molecules are compressed into small region places. The reflection are regions of low pressure, where the air molecules are spread apart. This alternating pattern of compression or reflectional is known as sound wave. Rope. You create a transverse wave by including the particles that make up respective medium and motion perpendicular to the direction of propagation. In your case, the medium will be the rope. When you move the rope up and down, you create motion in the particles that make up the rope. This motion will create high points, called crest, and low points, called troughs. The particles themselves will only move perpendicular to the direction of propagation, but the wave itself, the crest and troughs, will move along the direction of propagation. Microwave. Microwaves are a type of electromagnetic radiation, as are radio waves, ultraviolet radiation, X-rays, and gamma rays. Microwaves have a range of applications, including communications, radar, and fire-ups, best known by the most people cooking. Electromagnetic radiation is transmitted in waves or particles at different wavelengths and frequencies. The part of range wavelengths is most known as the electromagnetic spectrum. The spectrum is generally divided into 7 regions in order of decreasing wavelength and increasing energy of frequency. The common designations are radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Microwaves fall in the range of the EM spectrum between radio and infrared light.